Hi, this is King of Review. Is there a point of intersection between the two graphs, y equals 5x plus 1 and y equals 1/2 x squared? So one method for solving this problem is to use substitution. We have an equation here that solves for y equals 5x plus 1. So I'll substitute 5x plus 1 into the second equation for y, like this. So we have 5x plus 1 equals 1/2 x squared. Now I want to get a 0 on one side of the equation, so let's move the 5x and the 1 over to the right-hand side. So I'll subtract 5x on both sides, and I'll subtract a 1 on both sides. Now I have 0 equals 1/2 x squared minus 5x minus 1. This equation is now in the following form. 0 equals ax squared plus bx plus c. When we have an equation in this form, we can solve for x using the quadratic equation. The quadratic equation is x equals negative b plus or minus the square root of b squared minus 4ac, and this is all divided by 2a. The a, b, and c values come from these numbers here. So on our equation, a equals 1/2, b equals -5, and c equals -1. Let's plug these three values into the quadratic equation and solve for x. So we have x equals minus a -5 plus or minus the square root of -5 squared minus 4 times 1/2 times -1, and this is all divided by 2 times 1/2. When you simplify, you get x equals 5 plus or minus the square root of 27. So we can calculate x. It will have two values. One will be calculated using this plus sign, and the other is calculated using this minus sign. So we have x equals 10.2, and we have x equals -0.2. So notice we have two values for x here, and these are real numbers. So this means that there is a point of intersection between these two graphs. In fact, there's 2 points of intersection because each of these x values here represent the x-coordinates of the points of intersection. So there are in fact 2 points of intersection because we are getting two real numbers for the answer here. So letter A is correct. But I'm going to go further with this problem, and let's solve for the y-coordinate so we can see what the graph of these two equations would look like. So to solve for the y-coordinate, we already know the x-coordinates of these points of intersection, but to find the y-coordinates, we can plug both of these x values into either one of these two equations and solve for y. I'm going to choose the first equation, which is y equals 5x plus 1. So plugging in the first value for x, I have f of 10.2 equals 5 times 10.2 plus 1. This is how you would solve for the y value. So 5 times 10.2 plus 1, and this gives us a y value of 52. So we have a point of intersection at 10.2, 52. This is one of our points of intersection. And now let's plug in our other x value, f of -0.2. This equals 5 times -0.2 plus 1. And this is how you would solve for the y-coordinate of our second x value. So 5 times negative 0.2 plus 1, this equals 0. So we have a point of intersection at negative 0.20. So these are the 2 points of intersection. Now you could also solve this problem by graphing both of these equations. You could use your graphing calculator and then see where they intersect, count the number of intersections. I'm going to plot these by hand so that we can get a visual of what they look like. So we have our x-axis and our y-axis here. So this first equation, y equals 5x plus 1, we know that this is a line because it's in slope-intercept form. Slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. So let's plot this. Okay, so I'm ready to plot now. Okay, so we have a y-intercept of 1. This is the b value. This means that our graph crosses the y-axis at 1. So I'm going to put a point right here. Our m value is 5. This means that the slope is 5. So up 5 over 1. That would be right about here. So now we can use these two data points to draw in our line. So here's our line. And now let's look at the second equation, y equals 1/2 x squared. We know that this is a parabola because it's in the form y equals ax squared. So we can plug in a couple of values for x and solve for y so that we can get some coordinates to plot. It doesn't matter which values of x you choose. I'm going to choose f of 0. And so if we plug this in, 1/2 times 0 squared is 0. So we have a point at 0, 0. Now I'm going to plug in the point 1. F of 1 equals 1/2 times 1 squared, and this is 1/2. So we have a point at 1, 1/2. And if you plug in a 2, f of 2 equals 1/2 times 2 squared, and this gives you 2. So you have a point at 2, 2. So let's plot this parabola, and I'll do this in red. So we have a point at 0, 0, that's right here. We have a point at 1, 1/2, which is right here. We have a point at 2, 2, which is right here. So now I can plot the right-hand side of the parabola. And we know that there's an axis of symmetry on a parabola, so the left-hand side would mirror the right side. So this is going to look something like this. So we have our parabola here, and you can see that it intersects here. And if our graph was larger, both of these lines would continue. This line would continue, and this parabola's line here would continue until they intersect again. And that would represent this point here, 10.252. And then right here we have our other point of intersection. Thanks for watching.